introduce me.
Hello, everyone. I'm Scott Smelter. I'm one of the co-founders of United Consulting. Thank you for joining another United Consulting seminar, online seminar, which, by the way, we have started in-house seminars as well. If you are in the Atlanta area, please come join us. We have some very impressive speakers today, and I just want to say a minute about, for those of you who don't know United Consulting, we provide environmental services, geotechnical engineering, geophysical services, and construction materials testing for a wide variety of public and private projects for the last 33 years. From the Atlanta Beltline to Hartsfield-Jackson's Fifth Runway, and lots of projects in between. So Tim Echols is going to introduce our speakers here in a minute, and look forward to having you join us both today and in the future. Thanks for joining us.
Thank you very much, Scott. Thanks for all you guys do to make Atlanta a better place. You've got some talented folks working there. Appreciate that. Welcome, everyone. Very exciting week. All eyes are on the Augusta, Georgia area, not only because Tiger Woods is playing again at the Masters, but just down the river, Plant Vogel's now putting electrons on the grid and generating power. We're very excited to have Jeremiah Haswell from the plant here today. He's a UAB, University of Alabama, Birmingham undergrad and Masters. And then we'll hear from Seth Grae in the second half of our Zoom today as we talk about advanced nuclear and the tremendous push it's getting from the administration, from tax benefits, and from state commissions now across the nation. So let's get started with Jeremiah Haswell. And Jeremiah, I was up early Saturday morning, and I guess it was Saturday morning that you guys connected to the grid. So congratulations on that. We're really looking forward to seeing Unit 3 in commercial operation.
Yes, sir, Commissioner Echols. It was a great morning, Saturday morning, 4:34 a.m. Synced Unit 3 generator to the grid for the first time, and we're still producing megawatts today. So doing a lot of startup testing right now at the site and going through the different licensing basis required tests to make sure everything operates as designed. And we'll be producing power there from now till the next 60 to 80, maybe 100 years. So true, infrastructure, long-lasting project. So thank you for your support. So to give an update on Vogel, here's a picture, a recent one of both units there, 3 and 4. And we'll go forward. So here's kind of the overview of the project in a nutshell. We're building 2 Westinghouse AP1000s, a little over 1,100 megawatts apiece, located down in Waynesboro, Georgia. So about 45 minutes southeast of the big event that's happening. Our peak construction workforce was about 7,000 craft on site. And so that led to almost 10,000 total people on site. We're now down to less than 1,500 craft on site, really just focused on finishing Unit 4. We do have co-owners with the Oglethorpe Power Corporation, who serves Georgia EMCs, and then MEAG, which is the Municipal Electric Authority of Georgia, serving 50 different municipalities in the state, and then Dalton Utilities, who owns their own distribution grid up in Dalton, Georgia, and we supply power to them as well. So our regulatory approved CODs, November 21 and 22, that was the updated schedule after Westinghouse went bankrupt. We are behind that, but we're getting it right. So we're taking the time that's needed to make sure everything's tested is 100% correct. And now we loaded fuel just last fall. We're in startup testing on Unit 3. We're currently in hot functional testing on Unit 4. So we're taking it through its paces as well. So forecasted CODs, May to June for Unit 3. So right around the corner. and then the end of the year to first quarter of next year for unit 4. Total cost is about $10 billion for Georgia Power. About 7 of that is what the commission approved us to go forward in 2017. And we've spent to date about 9 billion, 9.4. So about a year left, wrapping it up. And the project is over 98% complete at this time. So here's a picture of what the plant looks like from Westinghouse. The right side, the turbine island, the steam plant, is what you would see at most nuclear power plants in the country. The left side is a little different, and it's because of our advanced passive safety features. And so you can see there's a tank of water inside containment that holds about 500,000 gallons of water. There's also a tank on top to cool containment that holds 750,000 gallons of water. So you can look at the schematic there and see how the water cycle cools containment, cools the reactor in any type of design basis accident. There's no operator action needed for 3 days. There's no outside electric needed to safely shut down the plant. You've got all the DC battery power there on site to shut the plant down safely. And you've got all the cooling water you need to also do that. So yeah, I like to tell people, if this was the design in Fukushima, we would still know Fukushima for the incredible natural disaster that happened with the earthquake and tsunami, but we wouldn't hear about it from the power plant because this plant would have been able to safely shut down in that situation. So that's what it looked like in the pretty picture. And here's what it actually looks like in real life now. So it looks very good. Here's a picture inside containment. So leading to fuel load, we had to verify all of our ITACs. So that's the inspections that the NRC laid out in our licensing basis. So we had to ensure that they were all complete, all the testing was complete, and all the acceptance criteria was met. At that point, we cleaned containment to it looks like this, clean enough you could probably eat off the floor, even though you probably don't want to. And then loaded fuel in October. So fuel load was a huge day. Took 4 days to load all 157 assemblies. And there's a picture right there of all the fuel in the reactor vessel. So it's a pretty nice view. And post fuel load, we started doing additional testing. We did our low power physics testing, did a lot of different temperature testing at the plant, and then went critical just about a month ago. So brought the unit up to criticality. So we started producing as many neutrons as you're absorbing. So you start the chain reaction inside the reactor at that point. And so now the reactor is producing enough heat to send steam over to the steam turbine side. And just Saturday, we synced to the grid for the first time. And so now we're actually outputting power as we continue to do our testing. So here's a picture of the control room. There's the unit 3 cooling tower. You can see the steam coming out the top. And I caution everybody, that is just water vapor. It's just steam. And then here's a picture of the turbine building. This is where you're sending that heat that you're making in the reactor to turn your turbines at 1800 RPMs. So on unit 4, it's good to show this, and you kind of are at the point where you can't tell the difference almost between the two units because they look so much alike at this point because they're nearing completion. You can still tell a difference inside, still under construction, but here's the turbine deck on unit 4. So still under construction, but you can see all the major equipment is there. We're testing it right now in hot functional testing, going to different temperature and pressure plateaus to ensure that everything on both the primary side and the secondary side work together. And here's a picture of the unit 4 main control room, showing you it's complete and in use by operators right now. And then here is kind of that final site picture again with 3 and 4. And this, once completed, this is the largest nuclear plant in the United States. So we've got 4 units. Currently, the largest is Palo Verde out in Arizona, but this unit will have a little bit higher megawatt output rating than those 3 units there. And then just follow up our current dates, May and June for COD on unit 3. We're in hot functional testing on 4. We expect to load fuel late this summer into the fall, and then COD by the end of the year, first quarter of next year. So there's the artist rendering of the 4-unit site. Any questions, Commissioner, or say those to the end?
Well, let's talk for a second. I know you and I went to China to see the work that they were doing. Let's see, they weren't in hot functional yet when we were there. Were they? What stage were they in when we went there 5 years ago?
Yeah, they were getting into hot functional. They were getting ready to do hot functional. They were doing
Yes.
some reactor cool testing while we were there.
Yes. So they've got theirs running. We're really close here. As you think about the importance of these assets with coal units closing, dispatchable power going away, what role, besides just producing carbon-free energy to the grid, what role would this plant play just in making the grid function properly?
Yeah, so just stability of the grid. It's a baseload asset, so it's going to run all the time. Breaker to breaker is our goal. So once you start this first cycle, you want to run until your next refueling cycle. So it's that kind of, we like to call it bottom of the stack base load power, that it's the cheapest and first source we put on every day. And since it's that bottom of the stack, it just stays on, provides that stability for the state. Georgia Power currently produces about 22% of our energy from nuclear. Once these 2 units go online, it'll be over 33% of our energy from nuclear power.
Hey, I want to look to my friend Meredith Angwin. She's author of Shorting the Grid. And I know, Meredith, you're very excited about this plant coming on. You've talked about the closure of Pilgrim up there and Vermont Yankee. And I just wondered about your thoughts as we are now getting really close. You have a question for Jeremiah?
I am just delighted. I mean, I'm very, very happy to see a new nuclear plant coming online in this country. We need them. People don't really understand how important baseload is, and you just can't make baseload with a bunch of renewables and natural gas plants. Not very steadily. Nuclear is just the best. I mean, that's my opinion. And congratulations to Georgia for having it happen.
Thank you. And you're right. It's that base load capacity that it's on every day, every minute when you need it. I mean, wake up in the middle of the night and turn the lights on, they're going to work because you've got plants like this that are operating around the clock. So.
People don't realize, I just started to keep talking, but people don't realize how many things are not because I turned the lights on. I mean, the refrigerators at our local grocery store are going all night. The industrial plants are going all night. It's water treatment plants. I guess what I'm trying to say is there's a lot of base load and a lot of it is really important to our health.
Yes, thank you. And I think that, us finishing this plant shows the industry that it can be done again. And so the industry as a whole, you're starting to see people pick up plans that they had before, and you're starting to see a lot of more discussion around how do we bring more nuclear to the grid to help, stabilize the grid with the renewables coming in. They're a good match together because you've got the sun out. You can help pick up that peak load with your solar, but you've got the base load covered with your nuclear. So it's a good mix. And I think it sends a good message to the rest of the industry that this can be done. And
Jeremiah, when you think about the impact of the plant, how many homes are we talking about with 3 and 4? And, will this power most of eastern Georgia, or where do you see the impact of the plant? We got Fort Gordon over there, close by, Augusta, Savannah just down the river. What's the impact of the plant?
So this site, conservatively, will power more than 1 million homes and businesses, the 4-unit site. So think of the impact of that on the state of Georgia. That's huge. Where the power flows from the plant, obviously there's a lot of transmission lines that run back to Atlanta, that run, to Fort Gordon and to a lot of industrial customers in the area. And it's power. It's interesting. It flows like water, path of least resistance. So it's going to go where the load is and where the need is. And that's the great thing about, our transmission infrastructure. And we continue to invest in that to help bring that power and that load to other areas of the state to help those industries and those customers.
I see Commissioner Patterson from North Carolina. Commissioner, I was at the beloved UNC Chapel Hill last week, not beloved by me necessarily, but in the Triangle. And
you didn't call me.
Yeah, and the Dominion president was speaking, Robert Ballou, I guess. But he was talking about, advanced nuclear for the future. And I mean, you were a former commissioner, serving in a role like I'm serving. How important is baseload power like this, do you think, with a growing load of electric vehicles coming down the line?
Well, Meredith just said it. You can't operate this country without baseload power. And to think you're going to have a green situation without nuclear is insane. We have to have this kind of power to operate this country as a first world economy. So I was at that plant when it was being built. I guess 2000. Oh, gee whiz. When we had the conference in Savannah, Tim, and
that was I think that was probably 12 or 13, 14.
Yeah, somewhere. And it looked nothing like that. It was just a lot of stuff. And we had the seminar there where the persons responsible for building it told us what would happen and all of the different steps and the challenges that they were having in finding the people to work on this plant. That was, as I recall, one of the big challenges was having the personnel to build it. So I'm hopeful that with this coming online soon, that those kinds of the success that this plant is going to experience will encourage more training and education in the whole nuclear space, and that we next time one is getting ready to come out of the ground, there won't be so many challenges around having the personnel to build it, because we got to have them, whether it's this type or whether it's the small modular units that seem to be coming on rather quickly.
And Seth's going to be talking with us about that. Jeremiah, I remember when Toshiba bankrupted Westinghouse, and it definitely sent panic through, at least through me and my colleagues at the time, and deciding to go forward, finding another contractor like Bechtel, and that was, the plant was on the bubble right then. Remember that?
Yes, sir. 2017. Remember it very well. It was definitely a challenging time. Toshiba did make good on their parent guarantee payment, so that really helped to lower the cost to customers. We also did take advantage of some federal incentives with the DOE loan guarantee agreement, which saves about $500 million in financing costs, and then production tax credits. So as we start generating electricity, we'll be able to get tax credits that are also going to be a straight credit to the customers, essentially. And that's over $1 billion worth of tax credits that we'll get over the first 8 years of these units.
Costas is on from Georgia Economic Development. Costas, as you think about you guys in Georgia Economic Development trying to get companies to come here and locate, do you get questions about baseload power, about our reliability, about cost? Is that something that comes up in your conversations?
With what goes on the energy side in Europe in general, and how the war has affected not just the people, but also their industries, the questions are the need for steady energy is very important. They were dependent mostly on sources from Russia, and now they're not coming. They're trying to change, and we're talking about the cost for them had during last summer had reached up close to $1,000 per megawatt. So yes, definitely the need for steady, inexpensive, and not so expensive energy. It's very important for the industries.
Thank you, Costas. Jeremiah, Jay asked, from the experience we have on this plant, what have we learned that can be applied to the future one, specifically the time that it takes to build the next one?
Yeah, I'd say a big piece of that is, and Commissioner Patterson hit on it, it's the experience level and the capabilities of the industry and the contractors and the workforce, keeping that at a high level to do nuclear construction work, which is, different from standard construction. You've got a very razor sharp focus on quality, and then on the paperwork that goes with it to ensure quality. And so keeping that workforce congruent, going to another site, building additional units. I think we see Bechtel and some of the contractors looking to do that with some of the SMRs at TVA and some other areas. And then keeping those suppliers, those vendors that are in-house US vendors, keeping their capabilities up to supply the current fleet of 93 reactors across the United States, but then also to expand and build new reactors again. So I think the commissioner hit it. It's really the skill level and the people that make it work.
I know my friend John Duke's on the call, and I've recently seen an op-ed that John has written. Excuse the police in the background here. John, maybe you have a short question on this. I know that you would love to see us do more solar, which we're doing a lot of, and more other renewable sources. You've heard kind of the positive comments here. What is there something, John, you feel like we need to consider?
Yeah, I mean, nuclear has a place. I mean, I'm not here to bash nuclear. I think I mean, I congratulate you on, getting these electrons to the grid on Saturday. I mean, I just think there needs to be a little nuance. I mean, I actually gave a presentation to my neighborhood association in defense of Plant Vogtle about 5 years ago, because my goal is, yes, carbon-free energy. That's the goal. But I just think that the lesson we learn here is nuclear isn't cheap, and it's actually it's great base power, but in the long run, in today's world economics and what's happening around the world, I mean, this is not my opinion. This is experts' opinion from around the world, is that renewable energy with some renewable energy, it can be done with batteries and backup can be done at a much cheaper rate. Yeah, there are issues with it. There are advantages to nuclear versus renewable, but if you're really trying to provide the cheapest rates to people, there are other ways that should be considered.
Let's do this, John. I'd like to go to Seth now for our next. Get Jeremiah to stop sharing his screen, because Seth kind of represents another segment of the nuclear industry. That's coming forward with this Generation 4 advanced reactor that we're hearing a lot about, not only from the industry itself and the nuclear complex, if you will, but also from TVA, from President Biden, from there's a lot of hopes about this. So Seth, why don't you share your screen, and I'd like to talk about maybe where we're going in the future with this. These AP1000s are very large reactors, 1,100 megawatts each, and we may not ever see anything that large built again. I don't want to say never, but it seems that as I talk with fellow commissioners who have to approve these projects, they're looking at these smaller, daisy chainable, easier, so to speak, modular, bring in on a train, bring in on a truck type of reactors. So Seth, you went to Brandeis, you went to, you got a law degree at American University, and then you went over to Georgetown, got a couple degrees. So and you're coming to us from Washington today. So with Lightbridge, thank you so much, Seth, for being on.
Well, thank you very much, Commissioner. And I want to congratulate Jeremiah and everyone at Georgia Power and all your partners, everyone at Southern Company for this great achievement. And, the Commissioner was very involved with this. And this is actually the first commercial nuclear power reactor ever to have an initial license application to the NRC that has put power to the grid. We've had reactors that the original application was to the Atomic Energy Commission and then finished under the NRC, but this is the first one to go through the current licensing process, and that also can help blaze a path for others to follow. And it's just a tremendous achievement by Georgia Power. And I'd like to pick up on what the Commissioner is saying and Jeremiah, and also what John is saying. First I'll say that at Lightbridge, we started by designing advanced fuels for the current types of large reactors, like the ones at the Vogtle site. But we've also started adapting them to focus on the new coming small modular reactors. What I'd like to lead up to here is why I agree with the Commissioner that I think the small modular reactors, the SMRs, will be the more important play in the future if nuclear is to play a major role in addressing climate change, which I think it will. And I'd like to go through a little bit about the scale of what we're looking at to do that and how that can be done. So first, just briefly, this is a little bit of a view of some of the fuel rods that Lightbridge is producing, we'll be testing. We're partnering with Idaho National Laboratory and working at Pacific Northwest National Laboratory, working on advanced fuels for the existing reactors, the new coming SMRs, that will improve their economics through power uprates, through longer fuel cycles, while also enhancing safety and also enhancing proliferation resistance, which will be important if thousands of these will be deployed in over 100 countries around the world. So when we look at climate goals, the topic of today's webinar, what do we mean? We hear about a 2 degrees Celsius average global increase in temperature from pre-industrial levels by 2050, 27 years from now as a goal, or hopefully a 1.5 degree increase, not 2 degrees C increase. And how much new energy will be produced? What should the composition of that energy be to be able to meet the goal? And there were some people at Stanford Research Institute that was part of Stanford University in 2010. Now it's SRI International out in Palo Alto, who figured that it actually was very difficult to address this issue because all the different energy sources have different measures of units of input, of output. When you start to look at global energy needs, you get into quadrillions of units. It's hard to get your mind around that. So we talk about 1 million British thermal units of natural gas or millions of barrels of oil. And how do we levelize those? So they came up with something called a cubic mile of oil. That if you had a swimming pool, a mile long, a mile wide, a mile deep, and you filled to the top with oil, and you burned it in a standard oil burning power plant, how much energy would that produce? And how many of those cubic miles of oil would you need to produce all the power the world uses in the world every year? all the energy the world uses for all reasons, for transportation, for electricity, for agriculture, manufacturing, everything. When I've asked people this question, I've had answers in the thousands of cubic miles of oil, they assume. The answer in 2010 was actually 3. The entire world's all energy use was 3 cubic miles of oil use. Now it's about 4. So since 2010, we've increased global use of energy by about 1/3 and rising. And if we're going to meet the global energy needs as projected by the International Energy Agency and other major global energy authorities, how many cubic miles of oil will we need worth of energy in 2050? We're at 4 now. So the minimum projections we're seeing from these agencies are we'll need 6, a 50% increase in how much energy the world will need. Some say the equivalent of 9 if we really lift a lot more people out of poverty in the world. There will be need for 9, but let's say 6. So it really is sort of 6 new cubic miles of oil equivalent of energy generation, because we have to replace so much of the current energy generation from fossil fuels if we don't have economical large-scale carbon capture, which is looking very unlikely in the next 27 years. So let's just go through a few of the non-carbon ways, really all of the major non-carbon ways we could produce even 1 cubic mile of oil of energy equivalent in a world that will need 6 or 9 of them. So just to, again, get back to what I'm talking about, 1 cubic mile of oil of energy equivalent will be 152 quadrillion British thermal units of energy. So it's easier to say 1 cubic mile of oil. So we'll stick with that. So if you look at the largest concentrated solar parks in the world, to produce 1 cubic mile of oil of energy equivalent, we would need to build 74,000 new ones and not lose any of the current ones. That would be 6,250 of them, 2,652 of them per year, every year between now and 2050. We've added 8 in 2020, and the 5-year average is going to get us to that collectively solar parks built between now and 2027, if built at the current rate, would be 0.11% of 6 cubic miles of oil, or about 2/3 of 1 cubic mile of oil. So no matter how much that increase, it's not going to contribute that much to global energy needs. Solar roofs, you start getting to, we would need to put them on pretty much every roof in the world. We would need to add over 1.3 billion roofs filled with solar between now and 2050 for 1 cubic mile of energy equivalent. The 5-year run rate is actually pretty high. We get to about, in the end, by 2050, about 28% of the global goal, but we're going to start to run out of roofs to do this on, and the people willing to pay for this, but this could contribute something. Wind turbines, we would need to add about 4.3 million of the large ones. We're on pace at the rate they're being deployed to get to about 28% of 6 cubic miles of oil equivalent of energy. So that's something, but that's a lot of reliance between solar and wind on rare earths, on minerals from China, from mining, from Congo, and supporting some very undesirable labor practices as well, and relying on other countries for our energy needs, and really not providing anywhere near the amount of energy we would need, let alone around the clock baseload that Meredith was talking about. And what about hydroelectric dams? This picture is the Three Gorges Dam in China, the largest in the world. We would need to build 797 more of them by 2050 in 27 years to make 1 cubic mile of oil of energy equivalent in a world that would need 6 to 9. At the 5-year run rate of deploying dams, we get to 8% of the 6 cubic mile of oil number. So what about nuclear reactors? If we look at a typical size, large pressurized water reactor, and the capacity factor on that, and the run rate of how these are being deployed in the world, we'd get to about 2.5% of 6 cubic miles of oil of new nuclear if we keep doing nuclear the way we've been doing it. So what this adds up to in the end is about, almost 60% of 6 cubic miles of oil, or 39% of 9 cubic miles of oil if we lift many more people out of poverty in a more energy rich life by 2050. And where's the other 61% of clean energy going to come from in the next 27 years of global energy? I noticed this Scientific American quote from May 1967, which said by the year 2030, in the absence of any other large source of energy at reasonable cost, fission power could supply about 85% of this need. That was in May 1967, and actually fairly closely matches up to what we're facing. So, and again, if you look at the need for energy-rich lives to lift over 1 billion people out of energy poverty who are still in it, then we're going to about 9 cubic miles of oil of energy equivalent that we'll need, and we don't even come close. So how could we get there? Well, one thing I was thinking about as an analogy is military aircraft in World War II. The day Japan bombed Pearl Harbor, the United States was at a rate of producing about 9,000 military aircraft per year. By the time the war ended, about 3.5 years later, the United States had produced over 300,000 military aircraft that were necessary to win the war. And we did that by changing to aircraft that could be built on assembly lines, not hand-built, and mass production of them. And those aircraft are about the size of small modular reactors. And if nuclear is going to play a role to quantify this, now bringing it into numbers of nuclear, the 6 cubic miles of oil of energy equivalent would be about 14,000 AP1000s. So, real congratulations to Georgia Power. Has one, will soon have 2. We saw what it took to get there, even with improvements in efficiencies and deployment. When I talk to the major vendors from Westinghouse to its competitors around the world, it's hard to add up to 200 more net increase in large light water reactors between now and 2050. In a world that would need about 14,000 of them if nuclear provided all of the new clean energy, the 6 cubic miles of oil of energy equivalent. Now, nuclear won't provide that all, but even if it provides less than 1/4 of that, it's still thousands of large reactors equivalent in a world that probably won't see 200 of them. As the commissioner said, we might not see another new one ever in the United States. So if nuclear is going to do a big lift, it's going to be these small modular reactors like military aircraft in World War II, built in factories in large numbers, shipped to sites with civil construction on the site. Now, is this possible? Well, we're starting to see big pieces falling into place that make it possible. We're seeing financing made available in Europe through what they call the taxonomy, as well as in the UK. The Inflation Reduction Act, the Infrastructure Act in the United States are bringing major funding to reactors. The Advanced Reactor Demonstration Program is cost sharing from the Department of Energy with reactor vendors to demonstrate their first units. But where could we put these feasibly that would make a lot of sense? And as the commissioner was talking about earlier, coal plant sites make a lot of sense. The Nuclear Energy Institute cites a study that showed that the coal plant sites that seem viable for small modular reactors could actually produce much more than twice as much power from small modular reactors as is now produced by large reactors in the United States. And why coal plant sites? Well, first of all, these are sites that have lifted people out of poverty, provided good jobs, powered the Industrial Revolution, have powered so much of our economy. And they have at them the electrical switchyard, the transmission line connections. You don't have to build out enormous amounts of transmission like you do with renewables. Labor at the site, skilled labor, even for some small modular reactors, use the turbine that's on the site for the coal plant. And coal plants in the United States, around the world, and then I would expand to fossil fuel plants, eventually natural gas plant sites, oil burning sites that are in many countries with similar advantages, connections to the electric grid right on the site, cooling water available nearby on many of the sites. And more immediately, I think there's a role for government to create demand for some of these reactors to pull these and everything needed through the supply chains. And we're hearing a lot about energy security as an important component of national security. And I could stop sharing the screen here. And for energy security, it's partly to get ourselves and particularly our allies off relying on Russia for fossil fuels, off relying on some other countries for fossil fuels, for grid resilience. But also, I think our military bases in particular are vulnerable, with so many of them being on the electric grid. And we could have military bases subject to cyber attacks on bases, cyber attacks on the grid, knocking out the base. We've seen the Nord Stream 2 pipeline under the sea could be attacked. Thousands of miles of transmission lines could be attacked. Getting military bases off reliance on the grid is an important national security need. The bases need the power anyway. They're paying for it now anyway. And if you try to back up a military base for long-term operation during a conflict by large-scale storage of diesel on the site, that itself would become a major threat and major risk to the base. So small modular reactors on military bases, I think, are very good for first or second use sites for many of the reactors that are being designed. And combined with the advanced reactor demonstration programs, the cost shares by DOE, could get us beyond first of a kind into second of a kind, third of a kind, fourth of a kind of a small reactor, getting closer to nth of a kind, justifying factory construction, real modular construction. And with that, I'll turn it back over to you, Commissioner, for the discussion. But I really think that if nuclear is to meet climate goals, it's going to be with large numbers of smaller reactors and actually energy security being a big driver to start demonstrating those small reactors.
Yeah, thank you very much, Seth. And I know we've got a lot of solar fans on the call, and I just want you all to lower your blood pressure a little bit here. I think about John, Mary Ellen Barker, with solar land acquisition, Eric, who put a comment in the chat, worked a lot with solar. Let me just tell you that on December 23rd, when it was really cold here in Georgia, 8 degrees, that there were a lot of power company employees who were, praying that we could make it till the sun came up and the sun started hitting our solar because it really gave us a tremendous boost. So it's not a zero-sum game here where we're saying that, we're converting the entire grid over to, nuclear reactors. No, each state in America gets to decide, how they're going to run their grid. And we certainly believe in Georgia, just speaking on behalf of myself and just looking at how my colleagues have voted, we believe that that natural gas plays an important role still way into the future. We're keeping a few coal plants open because of the dispatchable nature of those plants, particularly in North Georgia. I think of all of the utility scale solar that we have, and we continue to put. I mean, Georgia is going to be 4th in the nation and install solar next year, so it's not nuclear or nothing, and we're certainly not saying that. I want to go to a couple of comments in the chat, and first back up to Charles Oppenheimer's comment about the room for reform within the NRC. Jeremiah, you've been dealing with them, for some time now. Seth, you as well. Could we see a scenario, Charles asked, where there's a bipartisan mandate to increase new nuclear versus almost killing the industry, he says. Let me go to you first, Jeremiah, and then you to Seth.
So with Vogel, we did go through a new NRC licensing basis process, Part 52, where we got our construction license and our operating license all up front, instead of the old process where you got a construction license and then had to go back after construction and ask for an operating license. And then the plant was somewhat at risk if the NRC had a change in administration or anything like that. So I think the new process, while it had a little difficulty because it was new to the industry, getting through it, future plants using a Vogel as a reference plant will be much easier to go through that licensing process.
Seth, sorry,
I was going to say, as far as bipartisan support, we have had support from both sides of the aisle. We've had, every Secretary of Energy out there on site from the last 3 administrations. And so those things to help incentivize the industry to continue. I mean, it's baseload carbon-free power, and both sides of the aisle support that.
I think about the craft, all the craft that we had out there, union labor. I've said it before, and I'll say it again, that craft labor, I think, really helped us keep bipartisan support for the plant. You really didn't hear criticism from folks in the presidential election or the gubernatorial election from either party. I think it has enjoyed bipartisan support, and I attribute that a lot to the fact that we're using union labor. Seth, what do you think on the NRC and the bipartisan question here?
Well, first of all, there is very strong bipartisan support for nuclear at the administration level, as Jeremiah mentioned, and also in Congress, in both houses of Congress. The NRC is a safety regulator. The licenses it grants are trusted around the world. It's regarded as the gold standard of regulators in the world, but it is too slow, it is too costly to go through the process, especially with newer technology. As Jeremiah said, this primarily falls on the first of a kind licensee. So Georgia Power with Vogel 3 and 4 has taken a brunt of NRC licensing, that those that follow on will have a bit of an easier time. And also licensing something that has not been built and operated can be gotten around perhaps by building and operating under another licensing authority. We're seeing GE Hitachi with the BWX300 deploying first in Canada on Ontario power generation, and then a license in the US based on actual operations, partly of that plant in Canada, would make the NRC licensing a bit easier. But I do agree this needs to be addressed. The first of a kind issue is obviously not just in regulation. As John had mentioned in the chat, you look at the projected increase in cost of the new scale small modular reactor, partly inflation through the supply chain with the price of steel and everything else. But that's also the projected cost of a first of a kind unit. I guarantee you that if there's enough new scale modules being built, enough new scale plants being built, that it's mostly factory built, shipped to the site, duplicated the same or extremely similar plant, one after the other, the future plant sites, which would be much, much lower cost. But like Vogel, this is taking the brunt of a first of a kind deployment and getting through it.
And as a financial regulator for the utility, I certainly didn't sign up for us to be a first of a kind and no one else following us on the AP 1000. And that's what it became. Fukushima, the bankruptcy, and the emerging technology coming forward. And that was unfortunate. And I certainly wouldn't saddle my ratepayers, I'm just speaking for myself, with any other project like that. It's someone else's turn, and I think it's the military's turn. I totally agree with you, Seth. Let's help, as a country, let's help our military bases with their reliability and resiliency goals. And let's see those reactors go there first. And then states can come along behind them after the price has been lowered. Jeremiah, let me go to you with this question from my friend Eric. He said, how is China comparing? They have hundreds of nuclear plants being built. Will they be able to get out of oil carbon faster than the USA? You and I went to China. We saw unscrubbed coal plants there. I think China was building 26 plants along their eastern shore. Those were big ones, but yet they're building more coal. Is it just because of the demand, or is it that they didn't want to put the scrubbers on those old units, and they felt it just better to build something? I mean, you've had some interaction because we poached some employees from those other units. What do you think about Eric's question about China?
Yeah, so they really are building a lot of nuclear units. I think there's 20 nuclear units under construction there now. They've built 4 of the AP 1000s, the same technology we just deployed, and they have plans for another, I think, 8 to 10 of them. There'll be variations of that design as they go forward, but their whole infrastructure is growing for the large population that is coming along with more electric needs. And so I think with the growth in nuclear, they're trying to not have as big of a climate impact as they would otherwise if it was all fossil fuels. But they still need their fossil fuels as well. And I don't know when they will start to shut those down as nuclear comes on board, or if they'll need both.
And honestly, and and Eric mentioned this, when Seth was giving the cubic mile petroleum example, it could be quite a while before we're able to close our fossil plants. This plant, I'm in Macon, Georgia right now, Plant Shearer is just maybe a dozen miles from me. And I've had some of the co-owners tell me, look, we're going to need this beyond 2050. Georgia Power might not need it, but these other co-owners very well may. And Plant Bowen, I think we're scheduled to close that plant by 2038, but I think there's a high possibility that my colleagues and I will postpone that. I think we're just watching, right? What's the impact of electrification going to be with vehicles, with buses, with drayage trucks? And, if we close it too quickly, we might not ever be able to reopen a fossil plant again. So I think we're wanting to hang on and make sure that we've got the dispatchable power that we need, Jeremiah, before we act too hasty. There's a question from Steve, as he says, the proliferation of modular reactors would needs a standard, like in the French approach, he says, not different designs. And I think, Steve, I've often said that, I do like the French model, where they're, where they're focused on, on one design instead of doing a lot. But Seth, you're actually out there, in the fray of this. I mean, obviously you've got an opinion about this. Is there a benefit to having these different models compete and make the best one win? Is that kind of where we're going with this?
I think that's the situation we're being forced into. There are many good models out there. There are none actually deployed and operating. And we'll see how the demonstration units do. We'll see which do better than others. There'll probably be some consolidation in the industry over time. But there are very different approaches being taken by many of these different companies. And it's going to stretch the resources of the regulators like the NRC. A lot of the supply chain doesn't yet exist to be able to deploy large numbers of many of these types of reactors, let alone even one. So there's still a long way to go. And as the industry customers coalesce around 1, 2, or 3 models that dominate, that will lead to more efficiencies.
Doug Nichols mentions about finding a way to close coal plants sooner than I seem comfortable with, and I hear you, Doug, and I hear John Duke, and I have a lot of advocates in my ear about this, and we're certainly pushing to add more megawatts of solar. We've acquired some wind in Oklahoma. We're keeping our dams operating and spending money on those. So I think there's a lot of effort, but I think as I look out this window towards Georgia economic development, and I see these big companies coming in, and they're asking about energy, and I'm pushing for electric vehicles and wanting more buses and drayage trucks and semis and 350 kilowatt chargers. I just know that on December 23rd, we used every single thing that we had and then some, and that we used every molecule of gas that we could get, including gasifying stuff out of our LNG tanks. I think we want to be prudent as we go forward to make sure that we aren't begging people to turn their washing machine off at 3 o'clock in the afternoon on a hot August day. It's just, and again, different states do it differently, and I'm not criticizing anybody else, but we certainly want to be prudent, as we move forward. And things may wind up different, and that's why we do this strategic planning every 3 years. Well, we're down to our last 5 minutes, and so I want to give away our gift cards today. As United Consulting has donated 3 $50 Cheesecake Factory gift cards, and the winners today are Matthew Montz, M-O-N-T-Z. Congratulations, Matthew. Jess Meeker, and my friend Bill Linton from Greenville, South Carolina. Congratulations, Bill. I don't even know, do y'all have a Cheesecake Factory in Greenville, South Carolina? Maybe you do. So just final words, Seth, from you, and then Jeremiah as we wrap up.
Yeah, I'll just say thank you very much. It's been an honor to be part of this discussion. I'll mention I saw a question flash by someone named Pete asking about the price of solar on the Lightbridge website. And this is looking back over an average of a period of years that financiers look to the average actual costs. And not all solar is utility level solar, which is cheaper, but mostly it gets back to Meredith's point that we're not comparing apples to apples here. Solar doesn't power at night. We don't have batteries that economically allowed for grid level battery storage. Solar is a very important part of our energy generation. It will be a growing part of our energy generation. but it taps out at a certain point of just how much of it can provide, when, as Meredith said, we need factories running at night, we need hospitals running at night, we need a lot of power at night. So it will be part of a diversified energy mix that we're counting on, along with wind, along with hydro, along with other non-emitting sources, but only with growth in nuclear power, I think mostly driven by small modular reactors. Within that diversified energy mix, that growth in nuclear power is what's going to allow us to bridge to meeting climate goals, or else we won't. If we don't have that growth in nuclear power, it just doesn't add up, given that there is nighttime and there is lack of wind all the time, that those combined will get us to the goal. We have to work together, and together we can get there.
Thank you, Seth. Jeremiah, last minute goes to you.
Yeah, I just want to say thank you for having us on. I appreciate all of the support and the congratulations. That's well taken. We are excited to bring this plant online and to serve our customers with this plant. And it goes down to, we need a balanced mix in the state. And this is a critical, long-lasting infrastructure project that's going to be here long past when I'm done. So 60, 80, maybe even 100 years. And that's just a huge testament to how long these plants can run, how safely and how efficiently we can run them from now and through the future. So thank you for your time, Commissioner.
And thank you, Jeremiah. Thank you, Seth. Jody wanted me to say that the PDH credit is available to you. If you will email her or me, we'll forward that to you. Thanks everyone for being on today. And I really appreciate the great questions in the chat. Appreciate our speakers today. If any of you do want a tour of Vogel or want to keep up with that, just send me an email and I will try to make that happen. Thanks so much.